All right, so let's talk about what's going to happen if you have a lower mass star that's a little bit more like the sun. How is its life cycle going to look compared to a massive star? You still start in the same place. You have a stellar nebula. That's where all of your dust and clouds of gases and things are in space. That will, of course, form the protostar, which will then form the star. But now, what you're going to notice is that we have an average size star that's born instead of a massive one. Still, that star is going to spend 90% of its time in the main sequence. Um, that time frame is going to be quite a bit longer than it was for a massive star. Could be billions of years, could be a couple of trillion years. Keep in mind, the smaller the star, the longer it can actually live. Our sun right now has been around for about 6 billion years, and it will be around for another 6 to 8. So if we look at the life of an average star, just like a massive star, there's going to come a point in time where there will no longer be any hydrogen atoms to fuse together. And so it's going to expand slightly and give off some of its energy in the form of the helium atoms that are bonding. When this happens, it becomes a red giant. Red giant expands and it cools. And of course, it obviously glows red. I have an example here of Gay Crooks, which is about 88.7 light years from the Earth. It is currently a red giant, and it is going through its dying phase. Here's where things are really different compared to a massive star. A red giant, instead of it expanding all of its energy out, collapsing in, and then blowing up, it sort of puffs away the remainder of gases that it has when it finally does die, and it becomes something called a planetary nebula. Uh, all the shell of gases and dust are sort of expanded outwards a little bit at a time, and they go for millions of miles. And that dying star, the only thing that ends up being left is a very hot core. The rest is just gases sort of spread out all around it. Once that planetary nebula has all the gases shed away, gases have sort of gone out into space, you're left with the very center of that nebula, which is a hot little core. It's about the size of the Earth. We refer to it as a white dwarf. There's still light and heat being given off, but it's only the core that's remaining. None of the rest of the star is anywhere in existence anymore. None of those gases are present. So, of course, this is going to take some time for the remaining light or the remaining energy from this white dwarf to sort of die out. But eventually it does after billions or trillions of years. And when that happens, all that we have left over is a black dwarf. It is a completely dead star. It gives off no light, gives off no heat, actually can't be seen in the sky because it is darkness. And again, like a white dwarf, black dwarfs are the size of planets, so they're definitely much, much smaller than the majority of our stars. So it's pretty easy to see how the life of an average star compared to the life of a massive star is very, very different. An average star's life is not nearly as eventful. You don't end in a black hole or a neutron star. However, keep in mind that all of our stars have given us all of the elements in the universe, all of the elements that we know of on our planet. Each time a star dies and new bonds are formed, we get all of these naturally occurring elements. So, thanks to stars, everything exists that's made of atoms and elements. And so, there is some importance to understanding the life of a star. It helps us understand what could potentially happen in our own solar system, what can happen to our sun, and maybe help us understand a bit more about the entire life of the universe.